on this thing, and I need to download these to be able to open it. So that's 1. 2 and 3. That looks like the same as the first. Different?
Which one?
I don't know. I'll find out in a second. How many attached files were there? 3?
3.
3 different pages?
Yeah.
Okay. Close that one out. So those 3 5s, 41, 42, and 43. Now we open that one with paint. All right. Starting with 4?
Yeah.
Okay. Let me label some things. Let me do it. Let me try it this way. No, I don't want to do it that way. It takes too long to close out. I'm just going to use the drawing apparatus and paint.
All right.
So first of all, it tells us angle 7 is 38 degrees.
Mm-hmm.
And then angle 10 is 102 degrees.
Uh-huh.
That's where we're going to start. What's the relationship between angle 10 and angle 1?
Exterior angles?
Are they the same, first of all?
Yes.
No, they're not. Notice that one's acute, one's obtuse.
Okay.
In other words, one is greater than 90, the other is less than 90.
Okay.
So if they're not the same, what are they?
Supplementary?
Correct. So what is angle 1?
Angle 1 is 78.
It's angle 2.
78?
No. Angle 2 is the same as angle 10.
Oh, 102.
Because parallel lines. In other words,
Mm-hmm.
2 is a corresponding angle with 10.
Mm-hmm.
Have parallel lines with a transversal.
Mm-hmm.
So what's 2? 102?
Mm-hmm.
What's 3?
3, 102.
Okay, each of these angles with regards to this part of the picture, there's only 2 angles there. In the part that I've circled, there's an obtuse angle, there's an acute angle, and every other angle is one of those 2 angles.
Uh-huh.
The nature of parallel lines and transversals. If I draw a parallel line and a transversal like that, I create all of these, I create 8 different angles, but there's only 2 unique angles. One's acute, one's obtuse, and they're either acute, obtuse, and the obtuse and acute are always supplementary. So that's the most important part to remember about parallel lines and a transversal. Very easy. There's only 2 angles that, in other words, what I've circled over there only has two unique angles. Every angle you're looking at there is either 78 or 102.
Uh-huh.
What is 3? What are 1 and 3? What are 1 and 3?
78.
Vertical angles.
Uh-huh.
Vertical angles are equal. So yes, 3 is 78. Because it's equal to 1.
Uh-huh.
What's 4 equal to?
102. What?
You got it. 4 is equal to
102.
which angle?
2.
Why?
Is there like all exterior like?
They're called vertical. No, forget that exterior stuff. Anytime you have two things like that, straight lines that cross, that angle's equal to that angle, and that angle's equal to that angle. So which one's 4 equal to in our diagram, not that diagram?
4 is equal to 2, right?
Okay, what's 2?
102.
All right. Now 5, we need to figure out 5 based on this angle, because all of a sudden when we're looking at 5, we're looking at two different parallel lines and a different transversal.
Uh-huh.
So which is 5 equal to?
5 is equal to 7.
Okay.
Or, yeah.
What's 5 equal to? They've given you 7.
38.
Okay. 6 is equal to what?
8.
6 is supplemental with what?
8.
Nope.
Or 5.
Vertical angle with 8.
5.
Okay. So what's the relationship between 6 and 5?
The exterior. I don't know.
What are they? What are 6 and 5? It's a linear pair. What are linear pairs?
Congruent.
And when you're dealing with parallel lines and a transversal, there's only two answers. Either an angle is equal to one angle or it's supplemental to another angle. When you have a linear pair like this, that's a linear pair. 1 and 2 are always supplemental. We don't know what they are, but we know they're supplemental.
Uh-huh.
So 5 and 6 are supplemental.
Uh-huh.
So they have to add to 180 degrees. So what's 6?
6 is 180 minus 30 is 142.
Okay. What's 8?
142.
Okay, why?
Those are the same.
As, what are they called? What are 6 and 8 called? Vertical angles.
Vertical angles.
Remember vertical angles, remember linear pair. Because that's all you're dealing with here. Vertical angles and linear pairs. So 6 is the same, or 8's the same as 6. Also remember, in this picture, it's the same thing. There's only two angles there. There's a 38-degree angle, and then there's the supplementary angle to 38. Every one of those 5, 6, 7, 8, 13, 14, 15, 16 is one of those two numbers. Either 38 or 142. One of them's acute, one of them's obtuse. You can actually answer all of these by just seeing if it's acute or obtuse. 9 is back up under that picture. So what's 9? It's either 78 or 102.
9 is 102. Or, no, 78.
11 is what?
140, or no, 102.
What is 11 relative to one of these other angles here?
Vertical.
With what?
9.
Vertical angles are?
The same. So 78.
78. That's the first thing you have to do is figure out whether it's vertical with an angle that we know. That's easy. Oh, if it's not vertical, it's a linear pair with something else. 12 is a linear pair with what?
12 is a linear pair with whatever. What's that number? 10? Yeah, 10.
No.
Or 11. 11.
Okay, it's also a linear pair with 9. But 9 and 11 are equal, so it doesn't matter. So there's only two angles up top that we cared about. Either 78 or 102. So it's one of them. Just look at it and you can tell what it is. Is it acute or obtuse?
Which one?
12.
Oh, that's obtuse.
Okay, so which angle is it? Is it 102 or 78?
102.
Okay, that's all you have to do on these is just visually look at whether you're looking at an obtuse angle. That's not really the way to do it. I prefer you do it by figuring out, is it a vertical angle with anything? Okay. Now, if we look at the bottom picture, where angles 13, 14, 15, and 16 are, every one of those angles is one of two numbers. What are the two numbers?
Which one?
13, 14, 15, and 16 are all one of two numbers. They're either this
They're either 142 or 78.
38.
38. Oh, yeah.
They have to be supplemental, these two angles that I'm talking about.
Yeah.
Okay. What's 13? Is it acute or obtuse?
13 is acute.
You know what? That's probably not the best way for me to teach you how to do this. Best way for me to teach you how to do this is, what's 15?
15? Like an obtuse way or what?
Well, the way they teach you in geometry, angle 7 and angle 13 are alternate interior angles, right? Alternate interior angles are equal. So what's 13?
So they're equal?
It's equal to number 7. Seven is 38. So that's what 13 is.
So 13
There's
is...
another way to do this. Let me show you. Instead of paying attention to this alternate interior angles, which I never have liked, 7, that angle right there is equal to what other angle in this picture besides 13? Think corresponding angles.
So they're equal. Oh, I'm so confused.
This angle right here is equal to that angle, always. These lines are parallel. So in this picture, angle 7 is equal to which angle?
Angle 7.
Based on this over here. 15.
15, yeah.
Okay, so 15 is 38 degrees. Now what do we know about 15 and 13?
They're the same.
Okay, that's why 13 is 38. Now how about 14? What's the relationship between 13 and 14? Actually, we're back to the situation where all four of these angles are either what?
102 or 78.
No, they got to pick
Or
the.
38 and 142.
Okay. So every one of
Oh,
them is either 38 or 142. What is 14?
142.
What is 16?
142.
There you go. This actually works pretty good. Well, only if I scribble off screen. Okay, same problem, only the picture's a little more complicated. But basically, we're dealing, unless I'm not looked at it fully enough, there's the top line with the arrow indicating it's parallel with that line, the bottom line. The top horizontal line and the bottom horizontal line are parallel.
Uh-huh.
And this line, this diagonal line, is a transversal. It just stops there and stops there. Doesn't change the properties. Okay? So, what they've given you is angle 2, which is 41 degrees. Angle 5, which is 94 degrees. And angle 10, which is 109 degrees. So we have to figure out all these other angles based on that. Let's start with 1. No, sorry, let's not start with 1. Start with 9.
Okay.
We can't immediately figure out what 1 is yet. So you kind of have to work some of these not in the order. You can't necessarily go 1 through 9 here. But remember, based on my diagram over here, this angle right there is equal to that angle right there. Well, what is equal to angle 2?
7.
Nope.
Or 6.
No, look at my picture.
What?
That's angle 2 right there. That's angle 9. You see why?
Yeah.
This is transversal. This is this line right there.
That'd be 3.
2 and 9 are the same.
9.
9. Here, look at this picture. That's a parallel line, and you have that. That means that angle is equal to that angle. Alternate interior angles are equal. Well, 2 and 9 are alternate interior angles. So 9 is also 41 degrees. Okay. Think for a moment. Angle 4 is equal to which other angle in the picture?
10. Right?
First of all, let's look at 4. We can't do 1 and 3 yet. We can certainly do 4, because we have 5 down there. So what's 4?
4 would be 109, right? Because 4 and 10 are...
No, forget 10. Look at 4 and 5.
So 94.
Nope, they're not equal. 4 and 5 are adjacent. Adjacent angles are not equal. They're supplementary. These angles are either equal or they're supplementary. Just remember that. Linear pairs are always supplementary. So 4 you can figure out quite easily. What is 4?
86.
Okay. So I'm going to label it up here. And I'm going to label 9 up there. And I'm going to answer 4 is 86. Now we can figure out 3. In other words, this is the way geometry works. You can figure out a piece, and then you can figure out another piece. So now I can figure out 3. How? How can I? It has nothing to do with parallel lines. It has to do with a triangle.
Okay. So
It's the sum of the angles in that triangle.
go to 180
Okay. How many do we have so far?
to,
At,
or what do you mean?
well, we got a 41 degree and an 86 degree. You got to figure out
Right.
the third angle. We know they add to
Okay.
180. So how do you figure out the third angle?
Um, 180, right? Or 0.
Okay. First of all, you never have a zero angle in a triangle.
Well then, but it's 180 already.
They have to total. No, it isn't. It's 127 already.
Oh yeah, 127.
So
Okay, so it'd be
supplementary to 127.
so 127.
180 minus 127.
180.
Okay, here, I'm going to draw this picture down here.
Oh, 53.
Okay. So that's angle 3, 53.
Mm-hmm.
Okay, we got 4, we got 9. I'm going to label that 53. What do we know about 1, 2, and 3? What do they have to total?
180.
Okay. Shouldn't have any hesitation there. That
Okay.
line is a straight line. All angles, in other words, if I have a straight line like this and I got 3 different, then 1, 2, and 3 have to add up to 180.
Mm-hmm.
If I have 4 lines, then 1, 2, 3, and 4 have to add up to 180. Because
Mm-hmm.
that is a straight line. That means all the angles have to add up to 180.
Mm-hmm.
So, what is angle 1? We can now figure out angle 1. If we know those 3 have to add up to
86.
180. What is it?
86.
Yeah, it happens to be 86. And that actually makes sense because angle 1 and angle 4 are corresponding angles
Mm-hmm.
with regards to the parallel lines.
Mm-hmm.
We actually could have done 1 the moment we did 4. I just didn't notice it. Besides that, there was this other clever technique that I wanted to show you, where once I have 2 and 3 figured out, now I can always figure out 1. So 1 is 86. Okay, let's go on.
Okay, so
Hold on, I'm thinking. 6 is the same as which 2 angles?
be 8.
Combined with 9.
Right.
In other words, 8 plus 9 is corresponding with 6. They're the same.
Uh-huh.
Thing is, I don't know what 8 is.
But can't we do, isn't it 53?
No.
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 Because 3 and 8 are,
No. If I'm looking at this with regards to parallel lines, this is the only thing I see.
uh-huh.
I don't see these 2 diagonal slanted lines with slope. Okay? In other words, the moment I do something like that, then I can say that is equal to that.
Mm-hmm.
But I can't say anything about it. In other words, that other vertical line on the left interferes with the parallel lines.
Mm-hmm.
So, angle 1 is 86. Don't know what angle 6 is. But I know 8 and 9 are corresponding together with angle 6. So for the moment, let's just say 8 plus 9.
So,
hold on. Angle 7 is 180 minus angle 6. And angle 8 is 180 minus angle 2 plus or minus angle 7. Hold up. Angle 8 is the third angle in that triangle. We know one side is 41, the other angle is 7. So I think we have to end up using two equations and two unknowns here. Let me see if I can write them. Let me scroll down just a little. So I have a little writing room. So, angle 6. Sometimes you just have to see these, and I might not be seeing something. But I can certainly write this. In other words, angle 6 is the same as the sum of 8 and 9. Because that angle is corresponding to that full angle. With me?
Yep.
Okay. And angle 8 is equal to 180 minus 41 minus angle 7. And thirdly, angle 6 plus angle 7 equals what?
Angle 8.
Look at 6 and 7. Always look and see if you see a vertical angle or a linear pair. What do you see with 6 and 7?
A linear pair.
So they have to add to 180.
Right.
Okay, I've got 3 equations, 3 variables. I got angle 6 variable, I got angle 7 a variable, and I got angle 8 a variable. So through substitution, I can solve for those 3. Not particularly easy, but I can do it. And here, let me demonstrate. Let me scroll down here. Ooh, I can't scroll down anymore. It's over here on the left in a different color. I'm going to do the algebra.
Okay.
Now, there may be something about this picture I'm not noticing, and I don't have to get this exotic, but I'm only looking at 3 variables in those 3 equations, and that's angle 6, angle 7, and angle 8. And I have 3 equations. So, I'm going to start substituting. I know what angle 6 is. It's angle 8 plus 41 degrees, right? Okay, so let's take the other equation that has the angle 6 right here and substitute. So I'm going to be looking at the bottom equation, and instead of angle 6, I'm going to write angle 8 plus 41 degrees plus angle 7 equals 180. Okay? Now, I also know that angle 8 is a function of angle 7. So I'm just going to substitute for that. Well, angle 8 is what? It's 139 minus angle 7, right?
Mm-hmm.
Shoot, that doesn't solve it. Leaves us with a number equals to a number.
Mm-hmm.
I got to look at this from a couple different perspectives in order to be able to do it. And we're kind of out of time, so let's go ahead and stop. Let me peruse this problem a little bit more, and the next time we meet, I can finish the solution on this problem.
Okay, cool.
Okay? That's probably the best way to
All right.
do this at the moment.
Yep.
Okay. I will, let's see, you have another session tomorrow, I think.
I
No,
think
Thursday.
Yeah, Thursday.
I will talk to you Thursday, Blake.
All right, bye. Thank you.
Bye-bye.